Hey guys, it's Mr. Stewart again with Activate. This is Science Week 4, and today we are going to be talking a little bit more about these monarch butterflies. So we've got the three passages, and this question is just on hypothesis 3. And so we're talking about the lipid use. Butterflies store or accumulate body lipids, and those are fats to store as energy at a later time. And this is the hypothesis 3. And hypothesis 3, if you recall from last week, hypothesis 3 uses monarch butterflies, and they need it during overwintering, but not migration. So O, not M. All right, which suggests that they don't store lipids before, but they store them during the migration. Therefore, lipid mass continuously increases from the beginning of migration until the end of migration. Now the question here asks, based on hypothesis 3, which of the following figures best depicts the change in lipid mass of a monarch butterfly from the beginning of migration to the end of migration? Well, that means mass continuously increases from the beginning to the end. So which of these graphs shows mass continually increasing from beginning to end? Well, here's this. It's increasing, but then it goes down. F is out. This one's decreasing the whole time. H is out. G is the same the whole time. That one's out, so it must be J. And look at that. It is increasing the entire time. Number 2 this week, we've got back to hypothesis 2 and 3 and 1. Assume that changes in the body mass of a monarch are caused only by changes in the mass of the butterfly's stored lipids. All right, the statement, the percent of a monarch butterfly's body mass that is made up of lipids is greater at the beginning of migration than at the end of migration is supported by which of the hypotheses? Well, that means that it's using lipids during migration. So remember, in 1, it was migration and overwintering. So it uses 4 migration. So it's going to have high and then lower at the end because it's using them. It has to store lipids again before beginning overwintering. In hypothesis 2, they don't need it for migration, or they do need it for migration, but not during overwintering. So this is M, not O. And this one, we remember it was O, not M. So it doesn't need it during migration, so its mass is not going to decrease in migration. So it's not 3. We can get rid of this one. It was 1 and 2. Well, we can't just select one of these, so we have to select C. All right, we've got a new passage, passage 3. And passage 3 is looking at greenhouse gases. Greenhouse gases like methane, which is CH4. They warm Earth's climate. All right. Figure 1 shows the concentration of CH4 in Earth's atmosphere and solar radiation intensity. So we've got solar radiation intensity, and we've got CH4 over here on this side. So we have CH4. And you notice that CH4 is a solid line, solar radiation is the dotted line. And when one goes up, they both kind of go. It's a nice up and down the whole time. So when solar radiation goes up, CH4 also goes up. Okay, so we're looking at this. Figure 2, we're not looking at figure 2 right now, but it says figure 2 shows the same types of data for the same reason over 11,000 years. What we have here is 250,000 years. So there's a lot of time in this question. Now, our question today is asking, one solar radiation cycle is the time between a maximum in the solar radiation intensity and the next maximum. Well, here's one maximum, and here's another maximum, and here's another maximum, and here's another maximum in solar radiation. And so we're looking at what this time period is. All right, we're looking at what this time period is. And so we're going from, let's say, we'll go this one, which is right here, and this one, which is right about here. Well, that's 250. That's from 200 to 250 is 10, 20, 30, 40, 50. So each of our lines here is 10,000 years. And so if we have from this point to this point, that's 10, 20, or yeah, 10, 20, 25, 26 or so. And so if we go from there, let's look at this one. This one goes from here to here. That's about 10, 20. And so, sorry, those were bottoms, but we can move those over here and look at those. It's still about 20. And so are we less than 15,000? No, we're between 15,000 and 35,000. So B is probably our answer. Let's go ahead and eliminate those. 35,000 years. 35 would be 1, 2, 3, 4 and a half. 3, 1, 2, 3 and a half. That's a lot bigger. That's 2 whole sections. So that's not it. And greater than 55 is definitely out. So B is definitely our correct answer. All right, we're moving into a different part of this passage. Remember, this shows methane, and it warms Earth's climate. Figure 1 shows a concentration. We're not looking at figure 1 right now. We're looking for concentration and solar radiation have increased and decreased at the same times over most of this period. Now, take a look at this question. All right, this question is a little bit new for the ACT because the question is asking something you should already know. This is a previous knowledge question. That should be a D. My pen is not working. So this is knowledge. So it's asking which of the following statements best describes the effect, the primary effect of CH4 on Earth's climate. Now, if you know what a greenhouse gas is, you know that greenhouse gases cause warming, right? You shouldn't need to read the passage, but if you do, you should know that this greenhouse gases is going to warm Earth's climate. So, what is our effect? All right. CH4 gives off visible light to space, cooling Earth's climate. This word cooling eliminates this answer choice. We don't need that one. CH4 gives off ultraviolet radiation to space, warming Earth's climate. Warming's good, but we're looking at ultraviolet radiation. Let's go back to that one. H says CH4 absorbs heat as it enters, cooling Earth's climate. We can get rid of cooling because that's not right. And now the J. CH4 absorbs heat that comes up from the Earth's surface, warming Earth's climate. So warming is good, and then it comes up from Earth's surface. Now, at this point, you've got a 50-50 shot. We've eliminated 2 bad answers. We can now guess if we need to. Now, hopefully, you don't need to guess, because we should know that the greenhouse effect does not do anything out of space. It keeps heat in. And so if CH4 is a greenhouse gas, it should be keeping heat in, all right, from Earth's surface, warming Earth's climate. So J is our best answer choice in that situation. All right, another new type of question. We've got a new passage. This passage is looking at pulling force required to move blocks at a constant speed and plotted pulling force in newtons versus mass in kilograms. And so this first graph is force on this axis, mass on this axis, and we have a constant increase. All right, we have a constant increase. This one is 5 over 1. This point is 10 over 2. And this point over here is 20 over 4. All right, so the slope of that graph is constant. It's always 5. Over here, we're looking at experiment 2. The student measured the speed versus time of the 2 kilogram block, a 2.5 kilogram block, and a 3 kilogram block. And so they've already labeled this 2, and the speed versus time. This speed is increasing at a faster rate. So this one is higher acceleration. You should know that increasing speed is acceleration. This one's a little lower acceleration. This one is a little smaller acceleration. So what we can say is that as mass increases, acceleration decreases. And that's just something you should know about this science, this topic, this physics topic. But we should also be able to tell that from this graph. So as mass increases, this is higher, the acceleration is going to go lower. Now let's look at our question. Based on figure 1, all right, so we can eliminate this figure for this question. Based on figure 1, the results of experiment 1 are best modeled by which of the following equations? All right, it says block speed equals 0.2 times the time, or block speed equals 0.5 or 5 times the time, or is it force? So are we looking at speed or are we looking at force? Now, mass and force. Do we have speed in there? No. So we can get rid of these two. We don't want to look at speed right now. We want to look at pulling force. And so which of the relationships is pulling force there? Is it going to be this times 0.2 gives us this number? Does this times 0.2 give us this number? Or does this number times 5 give us that number? Well, the answer is obviously that it's 5. So J is our correct answer on this one. Again, if you have any questions, come ask Mr. Stewart, and good luck on the ACT this year.